Right now, tonight, somewhere in the universe, a planet is being eaten. As you're listening to this, a world 1,400 light-years away is being pulled apart and swallowed by its own star. Its name is WASP-12b. It probably began its life looking much like our own Jupiter, like an ordinary gas giant, but it drifted too close to its star, and the star began to feed. The gravity is so violent that the planet isn't round anymore. It's been stretched into the shape of an egg, bulging toward the star on one side, pulled long on the other. And from that bulge, matter is streaming off it, a river of superheated gas flowing out of the planet and into the star. We can watch it happen. Every year, its orbit tightens. We've measured it. The planet falls a little faster, a little closer, 29 milliseconds shorter with every single pass. In a few million years, there will be nothing left of it at all. WASP-12b is the first planet humanity has ever caught in the act of dying. But here's the question I couldn't stop asking. When a star strips a planet down to nothing, what exactly is flowing away? What was this world made of? Because that's the strange thing about the worlds we've found out there. We can measure how fast they spin, how hot they burn, what color they are. But what they're actually made of, the substance, the stuff itself, we are only now, in the last few years, learning how to read. And every single time we read it, it's worse than we guessed. Tonight, we're going to 9 of them. Real worlds, confirmed. Not one of them a place you could stand. And every single one is a neighbor, not more than a whisper away on the scale of the galaxy. And we still can't tell you what they're made of. Maybe the most disturbing one is not the one being eaten. We start with heat. There's a rule that feels almost too obvious to say out loud. Stars are hot, planets are cold. A star burns. A planet sits at a safe distance, catches a little of that warmth, and lets the rest go. Kelt 9b did not get that rule. 670 light-years away, this planet's day side sits at over 4,300 degrees Celsius. That is hotter than the surface of most stars in the galaxy. A planet hotter than stars. And at that temperature, our question gets answered in the ugliest possible way. Ask what Kelt 9b's atmosphere is made of, and the honest answer is nothing that holds together. It's too hot for stable molecules to survive. Water, hydrogen gas, the bonds that hold atoms into anything at all are simply torn apart. On the day side, there is no chemistry left. No compounds, just single atoms, ripped loose and glowing. Imagine watching the building blocks of matter trying to come back together, only to be torn apart again every single orbit. The gas flows around to the cooler night side, and for a moment the atoms find each other again and snap back into molecules. Then the day side tears them apart once more. Forever. Every orbit. A world where matter itself isn't allowed to stay assembled. Not that just nothing could live here, that nothing can be built here at all. No rock, no cloud, not a single molecule. Ask this world what it's made of, and the answer comes back the same every time. Nothing that's allowed to hold a shape. 64 light-years away, there's a planet the exact blue of Earth from orbit. The blue that means ocean, sky, water, home. If you found it in a telescope and knew nothing else, the first thing you'd feel is something like relief. You'd be wrong. It was the first exoplanet whose true color we ever measured, and it really is that blue. The blue just isn't water. There's not a drop of it. It comes from the atmosphere itself, packed with tiny particles of silicate, the raw material of glass. And that glass doesn't drift, it's driven. Winds here move at over 8,000 kilometers an hour, many times the speed of sound, carrying those glass particles sideways in a storm that never stops, never calms, never ends. The most Earth-colored world we've ever found is a place where the weather is made of glass, thrown sideways forever. The color was the comfortable version. The material tells the truth. On Earth, weather is basically one substance changing its mind. Water rises off the ocean, gathers into cloud, falls as rain, runs back to the sea. Round and round. 200 light-years away, there's a world that shows exactly that cycle. Just not with water. K2-141b spins so close to its star that a single year there lasts under 7 hours. One side faces the star forever, and on that side, the temperature climbs past 3,000 degrees. That's not hot enough to just melt rock. It's hot enough to boil it. So the rock evaporates. It rises off a magma ocean as a thin atmosphere of vaporized stone. Supersonic winds carry that vapor into permanent night, where it cools and falls back as solid stone. On K2-141b, it rains rock. Our best models suggest that this world rains its own mountains back onto itself. We're still confirming the exact chemistry of this cycle. We just know it from the little light we can catch. But that's the point. For every one of these worlds, we're standing right at the edge of what we can read. And we keep reading. Which brings me to the world we got most wrong. 41 light-years away is a planet that was, for a while, the most valuable object anyone had ever found. When astronomers first ran the numbers on 55 Cancri e, its mass, its density, the chemistry of its star, one answer came back that was almost too good to print. A planet made largely of carbon, crushed under its own weight into its densest possible form. A world of diamond. Twice the size of Earth. A planet you could, in principle, see with the naked eye. Made of diamond. Except, it wasn't. As better data arrived, the diamond dissolved into a gas that no longer held. Then the idea became a bare rock wrapped in a thin haze of vaporized stone. And then, in 2024, the James Webb Telescope actually looked. And it found something neither guess predicted. A real atmosphere. Thick. Rich in carbon dioxide, bubbling up out of an ocean of lava. Not because this world could support life. It couldn't. It's too hot. But if even a planet this hostile can hold an atmosphere, calmer worlds might too. 3 times we asked what this planet was made of. 3 times the answer was completely different from the last. This is the whole thing, right here. We are not looking at a catalog of settled facts. We are watching the answers arrive and change in real time. Up to now, I've been able to tell you what each of these worlds is made of. Even when the answer changed, there was an answer. Here's the one where there isn't. 750 light-years away is a planet that is, in a real sense, almost invisible. Not because it's far, because it's dark. TRES 2b reflects less than 1% of the light that hits it. Coal reflects more. The blackest paint we can make reflects more. Nearly every particle of light that reaches this world goes in and doesn't come back out. And yet it isn't cold. It orbits so close to its star that it's heated to around 1,000 degrees. So it glows, faintly, a deep ember red from its own heat. A world of total darkness that still smolders. Now here's the part that breaks the pattern. We can name light-absorbing chemicals in its atmosphere: sodium, potassium, titanium, and none of them are enough. Not one of our models can explain how this world swallows almost all of its light. For every other planet tonight, we could point at the substance. This one we have measured precisely, and we still cannot tell you what it's made of. 430 light-years away is a world we've only ever seen once. J1407b. Not up close, as a shadow. The one time it crossed in front of its star, it didn't dim the light for hours. It dimmed it for weeks. There was only one thing that could do that: rings. Working backward from that long, strange eclipse, astronomers reconstructed a ring system around a giant planet. But not rings like Saturn's. Rings about 200 times the size of Saturn's. 120 million kilometers across. If they circled a planet where Saturn sits, they'd stretch across our night sky far wider than the full moon. And in the gaps between those rings, the data hints at something the rest of this list hasn't shown us once. Not matter being destroyed, matter being gathered. Moons, whole worlds condensing out of the disk the same way the moons of our own solar system once did. We're still arguing over what this thing even is: a giant planet, a failed star, maybe not even bound to that star at all. But whatever it is, for once, we're not watching a world come apart. We're watching one being built. That idea, worlds being built, takes us to the strangest three of all. The very first planets we ever found beyond our sun. Not around a living star. We think planets are born with stars. These weren't. They were born after the star died. Around a corpse. In 1992, before we'd confirmed a single planet around a normal star, we found 3 of them orbiting a pulsar. A pulsar is what's left after a star dies violently. A tiny, impossibly dense, spinning core, sweeping the space around it with radiation. 3 worlds circling that dead heart, bathed in its radiation. We nicknamed them after the undead: Drauger, Poltergeist, Phobator. And here is what no one can fully explain. The explosion that made that pulsar should have destroyed everything around it. Those planets should not exist. The best idea we have is that they were built afterward, assembled out of the wreckage of the dead star. A second generation, made from the ashes. We do not know how. The first worlds we ever found are made from the remains of something that died, and their existence is a question we still can't close. We started with a world being erased. We've seen matter torn into atoms, glass thrown sideways, rock falling as rain, a world built from a grave. Every one of them, in its own way, a place where the material is wrong. So let me end somewhere else, because there is one more world, and by every measurement we can take, it is one of the most Earth-like planets we've discovered. Kepler 442b, a rocky planet, a little larger than Earth, circling a calm, quiet star that will outlive our sun. It sits in the habitable zone, the distance where water could stay liquid. It catches about 70% of the sunlight we do. Of every world ever confirmed, it scores among the very highest for how Earth-like it is. Not a furnace, not a corpse. Possibly a place with ground and weather and a sky. And here is where our question turns quiet. Because I can't tell you what Kepler 442b is really made of. Whether it has an ocean, whether it has air, what its ground would feel like. It's over 1,200 light-years away. Too far to measure the way we measured the others. Too far to ever reach. We found a world that might be like home, and it sits at a distance we have no way to cross. We began by watching a world vanish into its star, and we could name every piece of it as it went. We ended one that might be the most familiar place in the galaxy, and we may never know what it's made of at all. 9 worlds. We can measure how they die. We're only just learning what they really are. And the ones we haven't found yet are still out there. Most of them impossible. All of them waiting. There is more to explore. See you beyond the stars.